What's up, Math Ninjas? Let's talk about where you would use logarithms in the real world and how they work, and how you can solve equations with them. And so let's start with a fun problem. Say I was playing a game with you and I told you I picked a number between 1 and 100, and I'm going to ask you to try and figure out that number, and there's a catch. You only get 10 tries. You can't just say, is it 1, is it 2, all the way through 100, because in the worst case, if I happen to pick the number 100 and you started with the number 1 and you just kept increasing your guess by 1 each time, that's going to take a long time because you'll have spent 100 tries. And say in my head, I chose a number that's such as 78. And I'm telling you right now, you only get 10 guesses. But here's the cool thing. Anytime you guess a number, I will either tell you one of three things. It's either correct, or you need to go higher, and finally lower. So our first approach for this problem normally would think about something like, okay, I'm going to have to guess one number at a time. And if I chose a number between 1 and n, where n is any number, in the worst case, assuming we didn't get lucky, you could spend up to n guesses, which is too many. But the fact that I told you only have 10 tries is a hint that we can approach this problem a little differently. And there's an application here to logarithms, and we'll get to that in a bit. But what if we actually graphed the numbers 1 to 100 on this line? I'm over here saying 78. And instead of thinking about going in the direction from left to right, what if we think about breaking the problem in halves? So if 50 is right here, and you guess a number, but I tell you that you're either too low or too high, we could then spend the next guess breaking the original size of the problem in a half. And so now, instead of having 99 numbers to guess next, it's going to be up to 50. But you might be thinking, okay, well, we still only have 10 guesses. So if we have 50 numbers to search from now and we have 9 guesses left, aren't we going to run out of chances? Well, the answer is no, because we will keep doing the same thing over and over again. So say, for instance, I guessed that the number was 30. All right. I tell you, you are too low. So what we do now is we have a new problem that's between 30 and 100, and you've spent one guess. Okay? So you've spent one guess, and now between 30 and 100, say you guess another number. I don't know, like 82. But 82 is too big, right? Because we know that the answer I chose is 78. So what do? I would tell you your answer is too large. So now we spent 2 guesses, okay? But we keep shrinking the problem space to a much smaller space to deal with. So now we know the answer is between 30 and 81. And you get the idea. And so this is where the concept of logarithms come in. When you break a problem in halves, you are doing something called binary search. And we're dealing with powers of 2. So thinking about the original space, after each guess, we keep cutting in halves until eventually we get to our answer. Now, keep in mind that based on your guess and what I actually chose, each guess that you've taken, that size of the problem may not be exactly correlating to a half per se, but you get the drift. So how does this relate to logarithms? Well, here's a cool thing. You may have learned this in school about logarithms, where if, for instance, you have the log of 100, right? You've got log of 100. If there's no exponent here at all in this little area, it's usually implied that it's log base 10. So log base 10 of 100 and log of 100 are the same thing. And what does this tell us? When you have, for instance, log base 10 of 100, it's basically saying 10 to what power would give you 100? Well, we know that 10 squared is 100, so x would be 2. So a log of 100 would be 2 in this case. Now, keep in mind that sometimes the log you're given isn't a perfect whole number for a power. Say, for instance, it's log of 99. Well, this answer is not going to be a whole number like 1 or 2, but it's going to be super close to 2. Okay, now that was log base 10. With this binary search that we just did, it's actually log base of 2. So what's cool about this is I gave you an original problem size between 1 and 100. All right, so what we can basically say is log base 2 of 100 gives you what? This right here is going to tell you the maximum number of guesses you're going to have to guess for any number that I chose. And so if we look at the powers of 2, right? You've got 2 squared is 4, 2 cubed is 8, and so forth. You're going to find that this is less than 10 maximum guesses I gave you. And you can do your homework to actually find out what log base 2 of 100 is. I'm going to give you a hint that it is not a whole number because you can't do powers of 2 and get exactly 100. You'll notice that the whole powers of 2 that are near 100, the one right before it's going to be 64 and the one right above it's going to be 128. So do your math on this one and see if you can figure out what 2 whole numbers this answer is between. That's going to tell you the total number of guesses that you need for a problem like this. So I hope that was helpful, and thanks for watching. Hit that subscribe button if you haven't already, and I'll catch you later.